Is the screen is visible to you, ma? Okay. See, listen. Assignment 1 and quiz 1, CAE 1, we have completed. Now, next we are going to see about assignment 2. So, I think the date will be on 5th October. So, I will put assignment 2 and you all understand that. Then followed by on November, CAE 2 will be there. So, assignment 2, I will cover only third unit. So, 2nd of November, we have uh, continuous assessment too. So there will be 1 month for that. But now this week we will see about the third unit. I think we have completed only half of the third unit. The remaining half is over. Okay, and you all understand that how they were taking the marks. Are you clear, ma'am? CAE 1 and CAE 2, 30 marks. Both the quiz combinedly 5 marks, 3 assignment 10 marks, and attendance will be 5 marks. So this will be the thing. I think to know the split up for the importance of assessment, assignment, and quiz, I am saying for you. Okay, and I think we well, we have discussed each and everything. Okay, today we start seeing the third unit, ma. Okay. So can you able to see that this will be our third unit. Okay, so far we have seen about PIC microcontroller. I think we have a small recap. What is CISC, ma? Please tell me what is CISC. What is CISC?
Complex instruction
Instruction
set
set
computer.
Yeah, very good, Arna Devi. RISC. What is RISC, ma?
Reduced instruction set computer.
Okay. Then any other? What is PIC? PIC. Full form of PIC.
Peripheral interface controller.
Peripheral interface controller. Who is the manufacturer for PIC?
Microchip.
Microchip, ma'am.
Microchip technology. Okay. Actually, you've seen this comparison of CISC and RISC will be asked in 2 marks. Sometime only rarely they will ask in 4 or 6 marks. Okay. And the all important very questions are PIC my architecture, memory organization. First ever Kavita ma'am. PIC architecture, memory organization, addressing modes, assembly language, instructions. Only 4 questions are there. 4 questions are important question. Okay. Now, can anyone tell what are the types of memories are in PIC microcontroller? PIC microcontroller, what are the memories, ma? I have to go to that particular slide.
Program memory, data memory, ma'am.
Very good. Program memory, data memory. But we will specifyly
EEPROM, ma'am. Electrically.
yeah. Program memory, data memory, RAM type, and data EEPROM memories are there. We have only 2 memory program, but we have specifically EEPROM memory is there. Okay. So I think these are about PIC. I told PIC. Rarely only they will ask a pin diagram and all. So here you need not to study about the PIC. You have to study about the architecture. Architecture, I think this diagram is enough for you to explain the entire architecture. Okay, this futures along with this diagram. Okay, these diagrams are there. How many ports are there, ma? How many ports are there? In PIC microcontroller, how many ports are there?
5, ma'am.
5 ports. Kritika,
ma'am.
tell me in port A how many pins will be there? Port A consisting of
6.
6 pins. Port B, port C, port D consisting of
8.
8, ma'am.
8 pins. Port E consisting of 3 pins. Okay. And,
Three.
you have to understand that my data memory and EEPROM capacity is given. What are the other features of PIC microcontroller? Anyone tell? What are the other features, ma? What are the main
Array
features?
CPP model, ma'am.
What, ma?
CPP model, ma'am.
Very good, very good. PP module. Then CCP. What do you sell? CCP only. CCP module, capture, compare, PW model, and then what are the other features, ma?
In and out ports, ma'am.
Yeah, that only we said port A, port B, port C, port D, port E. 5 ports are there. So 5 ports means nearly they allocated 33 pins here. 32 pins in microcontroller, but 33 pins we have involved here. Okay. Then how many timers are there?
Watchdog timer, ma'am.
Yeah, very good, very good.
Two
Actually,
timers, ma'am.
we have power up timer, startup timer, watchdog timer, and brownout reset and in circuit debugger also we have. So we all know the timer will not only supply the clock pulses, even with the reduced power supply also the timer will work. And watchdog timer, it's a nothing but even the pulses, we were counting the pulses. Even the there is a problem in software programming, the watchdog timer will comes into the picture and it will do the timer operation. Okay, brownout reset timer is mainly for to operate within a 2 volt. The brownout reset timer will be used. Okay, then any other purpose, ma? Ma? Timers. How many timers are there? She said capture, compare, PW model. Okay, timer 0, timer 1, and timer 2. So 3 timers are there. 2 timers are 8-bit timers, and 1 timer is 16-bit timer. Okay, any other purpose, ma? In
35 single wire.
rectify
35, ma'am.
35. Yeah,
Single wire
35
instruction.
instructions. Yeah, very good. 35 instructions only in the PIC microcontroller. Good, Aruna Devi. Then anyone tell Amma about serial port, serial communications, serial communication, ma?
Use protocol, ma'am.
Yeah, ma? Serial communication. What are the serial communications will be there? USART.
API protocol.
Yeah,
Inter-integrated circuits, ma'am.
yeah, very good. Actually,
Universal synchronous asynchronous transmitter.
yeah. USART, SPI protocol, I2C, then parallel slave port also there. But when you take 8051, we have only UART protocol only. But here which consisting of all the ports. Okay. And while we are discussing about that, what is the flash memory capacity here? Flash memory is actually flash memory. They are given now. What is the flash memory capacity?
8K, ma'am. 8K, ma'am.
8K capacity. Data memory is 368 bytes. Data EEPROM is 256 bytes. Okay. Then another important feature is it having 8-level deep stack will be there. Okay, 8-level deep stack will be there. And while you are coming on to the other thing, we have a registers will be there. Okay, we have seen that this is actually what I said now. This important diagram you can remember about. This is a big diagram. I think uh, this is I have given that. You can seeing by that you can easily understand what is SFR, ma? What is SFR? What is SFR?
Special function registers, ma'am.
Yeah, special function register.
Special
See,
function.
this is about oscillator frequency, internal oscillator, A to D converter. Then this is all about serial communication. This all about timers, and this is about instructions, and this is about capture compare module, then all 5 ports, power supply, then this all about memory. Are you clear, ma? So I think this diagram you can specifically denote about all that. Okay, this all then, and then I told you study at least about the 5 registers, that is very important registers. Here working register means what? It is nothing but a working register is a
Accumulator.
Accumulator.
yeah, working register is a accumulator here. So we are not going to learn all the registers. This is the 5 registers you have to remember: working register, status register, file select register, indirect file register, and program counter. Okay, and the status registers only I told you it is similar to our flag register. So the bank is selected, I have to use this, and then zero flag, auxiliary, that is digit carry flag and all this will be used. Okay, and what are the 2 types of addressing modes, ma? What are the 2 types of addressing
Direct
modes?
and indirect.
Very good. Direct addressing mode and indirect addressing mode. Direct addressing mode, 2 bits will be involved for selecting banks, and indirect addressing mode only one, and remaining with that we will select the location as well as bank. Okay, so instruction set, we have seen the 35 instructions. Actually here I gave you in different, but one tabular column which gives all 15 35 instructions. This is tough for you, kindly study this. Are you clear, ma? Arithmetic and logical, bit instructions, direct and program flow, that is change the branching instructions, then data transfer instructions, and lookup table design. I think this is very easy. By studying the entire tabular column, you will study byte oriented, bit oriented, and control instruction, but it will be combination of all the category. But while you refer this will be that. Okay, did you remember this? Till this will be your curriculum, am I correct or not? Till this architecture, memory organization, then architecture and memory organization. Actually memory organization is part of the architecture. While you're writing about architecture, you have to specify the memory organization. Sometime they will ask memory organization in detail, you have to explain it. Are you clear? And then the third one is addressing modes, and fourth one is instruction set. Only 4 questions will be there. I already told no programs, we are not going to study any program for the PIC microcontroller. Real-time applications, I have explained street light that glow on detecting the vehicle movement. Okay, whenever any vehicle is there, automatically what happen now, this infrared sensor will identify, and the transmitter will activate the receiver, and the receiver will activate the ports, and the ports will be enabled, and automatically the row light will be on. So this is the one real time example I have explained. And see, this is one of the program I have explained how the LED is blinking. What code it is, mom? Anyone tell what code it is? Tell me what code it is. Actually we have seen instruction set of PIC microcontroller, but seeing this, what code they have used?
Embedded C.
Yeah, very good. Embedded C it is. Okay, so embedded C is nothing but when you studied what you have studied the normal C programming, the same thing only. So I think they have defined the coding, and they defined the frequency. The main function has written, and TRISB. What is this, ma? TRISB. TRISB. What register? Actually we have studied 5 register, I told you, very important register: working register, status register, and another thing is what, ma? Indirect file register, file select register, program counter. That 5 registers are enough while you're explaining about the architecture. But TRISP, anyone remember? TRIS SA, TRISB, TRISC, TRISD, TRISE? What are these registers, ma? Yes, Kritika, tell me. Forgot. Data direction registers which will involved in All port A, port B, port C, port D, port E. We have studied now. Did you remember? TRISA. Okay, TRISB. Similarly, TRISA. Okay, TRISD as well as TRISE. So all the port have a corresponding data movement data direction register is there. That is TRASB or SA or SC, because five ports are there na, each ports correspond to. So TRISB means what? Data direction register. Kritika, put your mic in mute, ma. Kritika, where she went? Kritika. Okay, I have mute. Okay, port B. Okay. So what here we have put ma RB3. RB3 means what? Port 3, third pin. So LED should on. If I give 1, that refers to on. How many delay I have to create? 500. So during that delay, it will on, and I have to RB3 off. Then LED is off. Then delay. So what happened na? This loop has to, because while we didn't give any condition, so it doesn't check any condition, so it is nothing but an infinite while loop. So what happened na? The LED will keep on blinking. So this is one. Then oximeter also I have explained you. The oximeter, how the PIC microcontroller is used using photodiode. Okay, and we have seen that photo detector is there. So photodiode and photo detector, through that we can able to find out the our oxygen level as well as our heart rate. Okay, now we will enter into the new processor, ARM processor. Okay, ARM. What is the full form for ARM? While we are discussing about PIC itself, I have told you in this unit you are going to study about two processes. Even PIC we have studied about instruction set and all, but ARM processor it is not needed for us. We have to discuss about the register organization, modes, states, and architecture alone. So we are not going to discuss about the instruction set of ARM processor. We are just going to discuss about the ARM processor architecture and the register mapping only. Okay. What is ARM? ARM,
Advanced destination.
advanced risk machine. ARM is nothing but advanced risk machine. Okay. So you all understand that ARM, advanced risk machine, is the name of the ARM processor. In the ARM processor, there are so many ARM processors are there, but in our syllabus, we are going to study about ARM 7 processor. Okay, how we are having PIC 10F, PIC 12, PIC 16, PIC 18F is there now. We have studied PIC 16F. Okay, so similarly here also we are going to learn about ARM 7 processor. So this is the first risk microprocessor for commercial purpose they have developed this. We all know, while going for a microcontroller, one microcontroller to another microcontroller, what is the main criteria we have chosen? Low power and less cost. Okay, high speed. These are the main three important thing while we are moving from one processor to another power processor. Within low power it has to operate, the voltage should be have to fluctuate between 2.5 to 5 volt. The processor can capable to work. Then the second one is the cost should be very less, and the third should be there should be high speed. So high speed now how we will achieve ma? Low power means with the help of voltage level, or else we have to go with some separate oscillator, some 2 volt or 2.5 volt. It have a capability to operate the oscillator. High speed now how we will identify the high speed processor? What is the parameter?
Frequency.
Yeah, ma?
Frequency.
Yeah, very good.
Frequency.
Who is saying the answer, ma?
Or Sundarraj.
Vasantaraj. Very good. Sundar Raj, sorry, there is no Vasant Raj. Sundar Raj is there. Okay, so very good, Sundar Raj. Actually, the thing is, if I increase the speed of the processor, or if I want to increase the speed, there's nothing but a frequency play a vital role. So the oscillator frequencies keep on increasing, then obviously it denotes that my speed of the machine is get increased. So this is the 3 point they are saying. Okay, then ARM history. We all know in 70s and all the Intel processor, Zilog, Motorola have developed the processor. But while coming on to 80s and the 90s, what happened? The embedded microcontroller comes into the picture and slowly developed the microcontroller. So what happened? While moving ARM processor, 1983 Acorn computers. They are the first which is developed the ARM processor. They used the VLSI design team. But what is the main problem on a system on chip? Reasonable power source. Some problem they were facing while they are developing the ARM processor. So SOC in a system on chip. So what happened? 1990, the Acorn computer have a tie-up with Apple and VLSI. They have developed the ARM processor series. So while moving on to the technology side, the ARM processor is, so what happened now? How they influence by influence buying the number only, they have keep on upgrading the ARM processor. Are you clear, ma? Okay. So I think this image you can see the evolution of the ARM architecture. Actually, while you are, we can easily compare a PIC and microcontroller with the technology, but the ARM is somewhat advanced. In PIC, in microcontroller, which program we have used, ma? In microcontroller, which programming we have used? Yes. Anyone tell, ma? In microcontroller, which programming we have used? Yeah, tell me. Which programming we have used? I have explained with which program on that day. It also I have explained one ascending program and all. Hey, which programming we have used, ma? In 8051 microcontroller. I have to call the participants. Aarti. 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 Afzar Maidin. So the people is not inside. You just switch on and went somewhere. Huh? Ajit Kumar. I'm taking attendance.
Hello, ma'am.
Yeah, tell me which programming we have used in ARM 8051 microcontroller. Hey, which programming, ma? At least tell one instructions of 8051. Assembly language programming. Very good, Sneha. Assembly language programming is used. Which program we used? Assembly language program only. I have explained the entire microcontroller, but I said that embedded C is also we can accompany, we can use for microcontroller. Okay. PIC microcontroller. What is the instruction we have seen in a PIC microcontroller? PICMA. PIC is also what we have used. Ajit Kumar.
Ma'am,
Assembly language programming, same. You all understand, we are using microcontroller ALP only. Assembly language programming, write an ALP using 8051 to sort the number in ascending order. I am asking that question in a assessment now. So which programming we are using? ALP programming. Okay, can you all understand? ALP na assembly language programming, or I can use embedded C also. Okay, so but when you go for microprocessor, we can use only ALP only. Okay, assembly that microprocessor doesn't supports the embedded C, but microcontroller will supports embedded C as well as ALP. Okay, so microcontroller we have seen all the programs we have written only using assembly language. We didn't see any embedded C. We have used only assembly language programming. And in PIC microcontroller, we have seen ALP instructions. Okay. Okay, we have seen not a program, but I have explained one small program in assembly in embedded C. Okay, But when you come to the ARM processor, due to the evolution of this ARM architecture, what happened now? This ARM processor also supports assembly language programming. And then we all know embedded C is obviously will be there in ARM processor. Apart from that, we have a Java code is also that. Jacl code, we used to say Java code. So what happened now? Due to the advancement in ARM processor, what they happen now? They have involved so many instruction set which were involved in the ARM processor. You just go through this figure. First, they developed ARM 1, ARM 2, ARM 3. I think while developing ARM 1, ARM 2, ARM 3, the Acorn computers only will be there. Okay. So after that, what happened now? They are directly move into ARM M6 and all. Okay, ARM say M6, the version of ARM will be there. Then they move on to ARM 7 processor and on-chip debug. Actually, we have on-chip debugger. IC we used to say in-circuit emulator will be there. What is the purpose of that now? If I want to debug my operation, it's a nothing but a hardware which is used to find out the error in coding. Okay, it's a nothing but a debugger. Okay, so using that on chip debug, they move on to this version ARM 7D, ARM 7DI will be there. But we all know what is the how many bits they used, 32 bit. While move on to ARM 7 processor, that is 32 bit will be there. Then I'm slowly move on to that. Thumb instruction set comes into that. Actually, ARM processor, I have asked one simple question. Only Sneha alone answer for that. Which programming I'm asking? ELP. But here we are having three instruction set will be there. ARM instruction set will be there. Thumb instruction set will be there. Then Jacl instruction set will be there. So three instruction set. What is the difference between these three instruction set? Now, ARM instruction means if it is a 32-bit processor, now the instruction set length is also 32-bit. Okay, but when I go for thumb instruction set, the length of the instruction set get reduced, not the length of the bus or and all. Length of the instruction set. So it will operate in 16-bit instruction set. So when I move on to Jacl code, that is Java code, now it will be 8-bit. So while I moving on to ARM 7 processor, there are so many types of instruction set is involved in ARM processor. Then they move on to enhanced multiplier and all the next technology. Okay, 440 means thumb instruction set is also comes into the picture. Okay, then they move on to that and TEAG, that is what they used to say na. Once again, J test. No, actually TEG. They actually this okay. Actually, the next implementation is joint test action group. Okay, so in this joint test action group, what happened now? They will verify the design and tested using PCB. After manufacture, they have an option. So what happened now? The evolution starts from ARM1 to ARM10 to E. Okay, so they have a electronic design optimization will be there. So there are so many tools to optimize this. So ARM1, ARM2, ARM6, ARM7. What is the development now? ARM7, there is 32-bit address will be there. On chip debug that I told you, in circuit debugger will be there. While move on to the next evolution, they comes into thumb instruction set. So what happen now? One single processor can able to operate in so many codes. Okay, then moving on to that, the JASL instruction set is also comes into the picture. After JASL instruction set, they have used the JTAG. JTAG means joint extraction group. So automatically what happen now? Before they are going to verify one processor, they can able to verify the design and testing in a PCB board. Okay, so this is nothing but a on-chip instrumentation. So that is also available in the evolution of the ARM processor. So ARM1 to ARM10 processor is there. So now we are going to learn about ARM7 processor. But you have to know what is ARM7, what is ARM7 TDMI. Okay, so TDMI, because we are not going to study about the other processor, we are going to study only about ARM7. You all know, to understand, ARM7 is different from ARM7 TDMI. You all know this we used to say first evolution, second evolution, third evolution, fourth evolution. ARM7 processor is in the second evolution. ARM7 TDMI is in the third evolution. And now the fourth evolution is this processor. While we are moving on to this ARM7 TDMI, T stands for thumb instruction set. Okay, actually ARM7 is how many bit processor, ma? ARM7 is how many bit processor?
32-bit.
Yeah, very good. We all understand. You have to understand well. ARM7 is how many bit, ma? 32-bit processor. Okay, so the thumb 16-bit instruction set is there. Okay, then D stands for on-chip debug support. That is not available in the previous evolution. So on-chip debug emulator or support will be there. So automatically it's nothing but a hardware device, but you used to find out the error or used to debug in software coding. Okay, and enhancement multiplier. Actually in the multiplication process, we have a multiplier section is needed for us. So this is the enhancement multiplier section is also there. Then ICE, in circuit emulator. Okay, so all this will be combined, will be called as a ARM7 TDMI. Okay, T stands for thumb instruction, on-chip debug support, enhanced multiplier, and in circuit emulator. Okay, so this are all come. So we are going to study it about ARM7 processor only, not ARM7 TDMI. But you have to understand what is TDMI, because here they mention TDMI. Okay, so these are all the thing is there. J stands for JASL instruction set. Okay, J stands for JASL. T stands for thumb instruction set. Okay, and where ARM processor is popular. Actually, you have seen in the earlier 2000, we have used some flip phones, and we have used so many iPods, and then we have used some games and all. So at that time, the ARM7 processor are very popular. Okay, so we have seen that ARM7, this is for gaming applications, iPad, ARM9, Sony Ericsson, BenQ, and ARM11. While it tie ups with ARM processor, that Acorn with Apple and VLSA, what happened? The ARM11 is developed in Apple, iPhone, Nokia, and this a series they have used. So mainly this ARM processor is used in portable devices because of its low power consumption and reasonable performance. We all know, first point itself we have seen that the low power consumption and the cost is also less. So that's why ARM processor is very much popular in portable devices. You have seen all in the older version, you have seen the games, and in cameras, flip phones, olden days with the wherever we carry our portable meters, till that the ARM processor is popular. So they were saying that 32-bit embedded. So we are going to see what only 32-bit embedded RISC processor for ARM. Okay. So ARM is very powerful. Why ARM processor is very popular? Na? Because of its similar design principle and common instruction set is involved. While moving on one ARM processor to another processor, they have added the new features only. They didn't change the concepts. They didn't change the designs. So that ARM processor is popular from moving from one evolution to another evolution. Okay, so this is ARM processor comparing from 1995 to 2003. Okay, I think pipeline. What is meant by pipeline architecture, ma? What is pipeline architecture? Anyone tell pipeline architecture? Pipeline architecture. Hey, pipeline architecture, ma. You have studied in microprocessor also. Pipeline architecture. What is pipeline? Tell me, ma, what is pipeline?
Ma'am, another instruction will be already ready before when one instruction is getting executed, another instruction will be getting ready, ma'am.
Yeah.
For
Fetch, decode, execute. This is three pipeline architecture. I have explained you. What is the advantage on pipeline architecture? Now, if one instruction is executed in the third cycle, the second instruction will be decoded and the first instruction will be fetched. That is pipeline architecture. So ARM7 used three-stage pipeline architecture, but ARM9, ARM10, ARM11 will move on to 5-stage, 6-stage, 8-stage. So what happened? The stages get increases. So obviously the speed of the processor get increases. Okay, then you see the typical megahertz. What is the megahertz? Ma 80 megahertz, 150, 260, 335 megahertz. What is the frequency we have discussed in microcontroller? Ma 8051 microcontroller. What is the frequency? What is the frequency? How many times we have seen? 12. Very good. 12 megahertz. In PIC microcontroller,
20.
20 megahertz. 20 megahertz. Okay. So then milliwatts per megahertz. That is the losses they are saying. Okay, 0.06, 0.19. Because obviously when you go with high frequency, the losses is also get increases. That is not a much problem. MIPS. That is million instruction per second. So when you see that my processor frequency is get increasing now, my instruction execution is also increased. Okay, and here when you see architecture, ARM7 use von Neumann architecture, and but all the other ARM processor use Harvard architecture. What is von Neumann and what is Harvard? Von Neumann, Harvard.
Program memory and data memory. They are in single architecture is one Neumann, ma'am.
Very
If it
good.
is separated means Harvard, ma'am.
Yeah,
Program
very
and
good.
data memory.
Very good. Vijay is saying, huh? Who is saying that?
Sundaraj, ma'am.
Sundarraj, very good, Sundarraj. So von Neumann architecture, you see, while a star, even though it is a RISC processor, even though it is RISC processor, they used which architecture, ma? Von Neumann architecture. And multiplier. Multiplier, I told you, it's a 32-bit processor. So the multiplier section, we will see how to we can multiply 3 data at a time in the ARM7 processor. So while we are seeing about ARM7 processor, while what are the important things we have to know now? ARM7 processor is a 32-bit processor. Okay, ARM7 processor is a 32-bit processor, and the ARM7 processor is developed by Acorn Computers, and it is developed with a frequency of 80 megahertz. Okay, it is used three-stage pipeline architecture. Three-stage pipeline architecture na fetch, decode, execute. Only this three-stage pipeline architecture is used in the ARM architecture. And one more thing is it's a RISC processor, but it uses the von Neumann architecture. We all know 8051 use which architecture, ma? 8051 PIC ARM. Kindly compare along with CISC and one architectures also. Tell anyone have told the answer, please. 8051 use which architecture? Huh? Which architecture, ma? Tell me.
Harvard architecture.
Very good. Harvard architecture. CISC or RISC? CISC. Yeah, very good. Then PIC microcontroller.
Risk and hardware.
RISC and hardware. Very good. Harvard. And ARM processor.
Risk, hardware, and Von Neumann only for
Von
best
Neumann.
edition.
Yeah.
Best
Always.
edition.
Yeah, ma?
I mean, seventh edition. Seventh edition only Von Neumann, ma'am.
Yeah. So we are going to learn only 7th only. We are going to learn not going to learn ARM 9, 10, 11 and all. We are going to learn only ARM 7 processor. So 8051 use Harvard architecture. Along with that, they use CISC instruction because nearly some 255 instructions are there. But while moving on to PIC microcontroller, in PIC microcontroller, we have used Harvard architecture with RISC instruction. Because we have used only 35 instruction sets. While we are moving on to the ARM 7 processor, ARM 7 processor used Von Neumann architecture with RISC instruction set. But I told you here the instructions are we are using 32-bit instruction, 16-bit instruction, and 8-bit instruction set is available. 32-bit we used ARM instruction set. 16-bit now we use thumb instruction set. 8-bit now we will use the Java code. So that is the main processing of this. So you have to understand this. Okay. See, in this ARM 7, we have only this syllabus is there. ARM 7 architecture, register organization, modes and states. Only this much of the thing is available in the ARM 7 processor. Okay. So I think today we just touched the introduction part alone. Time is 10:20. Another 5 minutes. Okay. So pipeline, don't forget the 3 word fetch, decode, execute. Okay, because they will ask in 2 marks. Okay, fetch, decode, execute. It what it will do in the detailed version of the given processor is there. Fetching the instruction. So while I'm fetching the instruction, I have to capable, if I fetch the instruction, the next machine cycle will do now. What it will do, it will increment the PC. PC means what? What is PC?
Program counter.
Very good. Program counter. So program counter will always locate the current address of the instruction. So program counter only responsible to move from one instruction to another instruction. So it will always hold the current instruction set address. Okay. So what will fetch instruction will do now? It will increment the program counter and it is capable to read the next instruction. So obviously address selector, address incrementer, address register should be related block should be involved. Okay. Then decode. Decoding means decoding instructions will be there. So decoding in sense means I have to send the control signals. We all know the control signals will communicate to all the blocks. So read, write, status, all the signals will be in the control signal. So it will be synchronized with the all the blocks. So decoding means I have to generate the control signals. So I have to read from the register file and I have to generate immediately. Depending upon my instruction, I have to generate immediately. So what are the 2 files involved now? Register file as well as control logic. Okay, I told you decoder and instruction set will be involved in the decode block. Decode and instruction. Okay. The next one is execute. Execute means I have decoded my instruction. After decoding, execution has to be done. So what happened now? The particular code, assembly language, now it has to be converted into machine level language and then it has to execute the instruction. So what the execution? So all this will happen and after that the execution will what it will do now? Arithmetic and logical unit, branch, load, store. So all ALU part will comes into this execution. So fetching means fetching the instruction and program counter will get incremented. Decoded na, decoding the instruction, that means what happened na, it has to send the necessary control signal to the each and every block. Execute na, execute the instructions which is involved with the ALU unit. So this is the standard 3-staged pipeline architecture. Okay, actually you have to know, but because when we move on to ARM 10 and ARM 11, the pipeline is get increased. But you have to see ARM 7 and ARM 9 now. Memory and write is also involved in ARM. But ARM 7, it will be happen separately. But within the pipeline itself, the ARM 9 processor is working. So you just see the 3 instructions of ARM 7 processor. Okay, LDR means loading, NOP no operation, DCD na decrement the counter. So what happen now? If this LDR will be executed, at the same time, my second instruction is decoded. So the third instruction is fetched. So you have to understand, if so within this 3 instructions, what happened now? The first in within 3 cycle, the first instruction is executed, and the second instruction is decoded, and the third instruction is fetched. So within 3 cycles, all the 3 operations is happen in the each and every instruction. Okay, so ARM 9 means 5 pipeline architecture. Memory and write operation is also involved there. But in ARM 7, very important thing, it's similar to 8086. I'm saying similar to 8086. Fetch, decode, execute. Okay, and you have to see some ARM 7 features I have listed out. It is a RISC processor, 32-bit general purpose processor, and I told you high performance, low power, small size, low cost. All this thing will be comes into the picture. And large and regular register file is that we will discuss about the register file separately. Load store architecture, similarly load na, load from the memory, and store na, store to the memory. So load store architecture will be there. So pipeline architecture will be there, and uniform fixed length, 32-bit na, 32-bit instruction set will be there, and 3 address instruction is there, and the simple addressing modes are there. So these are the ARM features we are saying. Okay, now I think ARM registers and all we will discuss in the next class. Okay, so students, kindly listen while I'm giving the assignment this time. I actually how we gave assignment one more 5 part A questions, and am I correct or not? What is the assignment pattern, ma? 5 part A and 1 part B. Am I correct or not?
Yes, ma'am.
Yeah, this time is also the same thing only. 5 part A as it is. But part B, how I am going to give you now, you have to identify the real-time application of ARM processor and PIC microcontroller you have to write. Because these few people are very lazy. Even in examination, I have seen most of them have written same answer. So don't repeat the same answer. Now itself, I'm telling openly, you have to write the any one application, real-time application of ARM processor and PIC microcontroller. And one more thing, and this is not to be assignment. I ask you to present in a class. Okay, I will give you the time for you. Normally, you will take the seminar during your classes. Now, what happened? You whatever you are writing in your assignment, you have to give me. I will ask 10 people each day. So within 7 or 8 days, you will complete the real-time application, and we can totally some 96. Sagili Vijay Kumar only not attending the class regularly. So nearly 95 students were attending the class then and there. So what happened now? 95 applications you have to find out. Are you clear, ma? So this we will start from this Friday onwards. Is it okay for you, ma? Is it okay or not?
Okay, ma'am.
Okay. So what happened now? I told you that the first 5 register number 1, 2, 3, 4, 5 on Friday. Okay. On this Friday, you have to find out application in ARM 7 or PIC microcontroller. And one more thing, I gave 3 applications in PIC microcontroller. Don't touch that. Oximeter I have explained. Street light I have explained. And one more applications what I have explained. Street light, oximeter. Only these two I have explained. I think I have explained 3 applications. Glowing of LED. Yeah. Street light using PIC microcontroller, then oximeter, then LED blinking. That 3 I have explained. Don't touch these 3 applications. Are you clear? 1 is Aarti, 2 is Abhirami, leave Afzar. Okay. 4 is Ajit Kumar, 5 Akash Singh, 6 Alagupriya. Till 6. Afzar, I will ask him to explain it later. So till Alagupriya, you are supposed to prepare one real-time applications in PIC microcontroller and ARM microcontroller. And one more option is given. You can take 8051 also. That is, if you are not getting that much of applications, because all are microcontroller, 8051, ARM, PIC, all are microcontroller only. So you can explain any one of the application in here. Are you clear? You have to start daily 5 members. This Friday onwards, we are starting. 8051 is how many bit microcontroller, ma? We take the attendance. 8051. 8051 dash bit microcontroller. Tell me. Jay Prakash, tell me Jay Prakash. 8 bit. Okay. PIC microcontroller. PIC is
8 bit, ma'am.
yeah. PIC is also 8 bit. ARM is
32.
ARM
ma'am.
7. Yeah. Understand? 8051 is 32 bit. 8051 is 8 bit. PIC microcontroller is 8 bit. ARM 7 is only 32 bit microcontroller. So people be ready and you have to present it. Are you clear, ma? Inform Abhirami is absent today. Okay. Aarti inform to Abhirami. Okay. Register number 1, 2 absent, 3, 4, 5, 6, 7, 8, 9 absent. What happened to him? 10 present, 11, 12, 13 absent. Hey, 5 marks for attending, man. Why, man, you people are doing? Yeah. 14, 15, 16, Bhavani absent. 17 absent. 18 absent. 19 present, 20 present, 21 present, 22 present. Chandralekha, what's your number, Chandralekha? 18. Okay. You didn't number. Yeah, Chandralekha.
Ma'am.
Okay, Chandralekha. 23, 24.
18, ma'am.
Okay, 25. 25 is absent. Darshini,
Ma'am, 16 present, ma'am.
16 present. Enga pona? Ella petiya. 26, 25 absent. 26, 27, 28, 29, 30, 31 absent. 32, 33, 34.
Illa, ma'am, network problem, ma'am.
Sorry, okay. 35, 36, 37, 38, 39 absent. 40, 41, 42. 43 present, 44, 45 absent, 46, 47, 48 absent, 49, 50, 51, 52, 53, 54, 55 absent, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67 absent, 68 present, 69 absent, 70, 71, 72, 73, 74, 76, 77, 78, 80, 81, 82, 83, 85, 86, 87 absent, 88, 89 absent, 90, 91 is absent, Vanmati is absent, 92, 93, 94, 701, 702, 703, Izad is absent. Balaji 31, I put present for you. Why you are at the last? Balaji is present, 31. Okay, ma. Okay, please, students, all of you prepare well for that seminar because sometime I will ask you to take. So everyone has to prepare separate topic. Don't repeat. Okay, I won't come in order. It will come from back also. So first five prepare from Friday onwards. Thank you, ma.
Ma'am, excuse me, ma'am.
Yeah, tell me, Jay Prakash.
Ma'am, when the college is going to start, ma'am,
I can't understand.
normal classes.
Normal classes. Oh, you are final year. People are expecting the normal classes. You are missing those years.
When
I
the,
will. Huh?
yes, ma'am. When,
Actually, we don't know when they are going to start because still now
yes,
we didn't got any information. So officially, when we got the information, we will regularly start the college. So we also don't like this online mode of classes. We people have to see your face, and I have to, because so many students were there here, but they are on there and they were went somewhere else. Okay, so we will see. Hope everything has to be well, and we will meet in person. Okay, ma. Thank you, ma.